Yeah. That sounds like a thank you, may I have some more while you're being mercilessly beaten, right? That's just no kind of good. Okay, so here's what's going to happen today. We start out with a recap of some fundamental stuff that we were talking about as an overview all the way back at the beginning of the semester. We're then going to focus explicitly on Chapter 9. If we have time, we'll do some Chapter 11, and then we'll anticipate Chapter 13. But in any case, like I said, by Tuesday, we'll have everything we need, right? It is the case that what we're learning builds on what we already know how to do. So if there's a struggle, cool, you're basically going back and scooping stuff up, right, when you're working on the new material. If it's now broken wide open for you and you say, yeah, I got this, yay, you can say, I'm going to build on what I already know, right? And maybe I deepen my understanding. Okay, so remember we talked about at the beginning of the semester this. We said that there are atomic sentences and there are compound sentences. And the atomic sentence or the atomic sentence is also a simple sentence. And there are two types, right? Which obviously one of which I obviously can't spell. There's the singular and the quantified. So remember, a singular sentence is a sentence that's about a named entity, right? So about a named entity. For example, A is a cube, right? The quantified sentence is about a class of thing that is an unnamed entity. For example, oopsie, I had 3 thoughts flying around and they came out in some weird notation. For example, dodex. And then the question is, how many? Right, so that's what we're going to push on. The compound sentence, as we know, is also singular, right? So it's going to involve at least one connective and at least one named entity. For example, A is a cube and A is to the left of B. Right? All of this you know, yeah? And then we can have also a quantified sentence. And here again, we have at least one connective and at least one quantified element. So we would say something like, not everything is a cube. Not everything is a cube. Okay. So I hope it's clear that we're going to enlist all the stuff we already know, right? So we have predicates, we have the parentheses for the constant, which is no longer going to be in play, and that's because in quantifier logic, we don't talk about named things. They're unnamed things. So our constant will be replaced with a variable. I'll get this on the board, but just as a verbal anticipation. We'll also continue to use our connectives, right? So everything you already know we're using. We'll also use parentheses to determine the scope of the quantifier. So think about, for example, when we use parentheses and a negation out front, the negation we know covers the scope of the sentence, whatever the main, if you will, the subconnective is, right? That negation's scope is determined by the parentheses. Well, we'll have a quantifier whose scope is determined by the parentheses. But we're adding, so our new notation is going to be the substitution of a constant for a variable and the introduction of our quantifier notation. Okay, so here's an overview of chapter 9. Let me also just point out that we won't formally, in terms of our homework, in terms of our exam, spend time talking about how we establish the truth or falsity of a quantified sentence. Quantified sentence, for example, rephrase. The truth or falsity of a quantified sentence cannot be established, for example, via a truth table. Quantified sentences aren't truth functional in a way similar to the identity symbol not being truth functional. Right? The quantified sentence resists the truth table, or the truth table is too restricted, right? It's restricted to just connectives and the way they operate on atomic sentences, the way they operate on compound sentences. So we'll talk about truth and falsity, right? But we won't we won't deal with, for example, the chapter 4 stuff and part of the chapter 3 stuff that involved a lot of truth table activity, okay? But what we will do, and this is going to be so much fun, we're going to take everything we know about chapter 6 and chapter 8, and we're going to bring it to bear in chapter 13, where we learn 2 more sets of rules, intro and elim, for our 2 quantifier types. There's a whole array of expressions. You're going to be fine, right? I know you're going to be fine. Okay, so we have 2 types of quantified, or sorry, let me rephrase that. Quantifiers, or 2 types of quantifier. Universal and existential. Right? The universal is affirmative or negative. Similarly, the existential is affirmative or negative. Right? So here's something that's kind of cool about what we're doing. I don't know if this will help, but I'm gonna offer it up. You remember that in chapter 3 and 7, we were introduced to connectives, the joints, the hinges, if you will. Well, negation's not like that, but the joints or hinges of a sentence. And then chapter 6 and 8 involved rules to assemble and dismantle, right? According to the truth definitions of those connectives. So in quantifier logic, right? So just as we had 5 and really 3, fundamentally 3 connectives, in quantifier logic we have just two types of quantifier, the universal and the existential. And then, so we have two quantities, and then we have two qualities or modes, to affirm, to negate, to affirm, to deny. Okay? So the cool thing is now, here's my point, is we're working on a logic of just ultimately 4 types of sentence. That's it. Okay? So one of the things we're going to want to do is look at the 4 standard ways that these sentences are notated in our new, not brand new, but new built upon our old notation from chapter 3 and 7. Okay, so here are some ways that we can start to think about this. So universal affirmative, all subject class are predicate class. Universal negative, no subject class are predicate class. Existential affirmative, at least one subject class is also in the predicate class. And existential negative, some subject class are not members of the predicate class. Okay. So, quick question for you. Is anybody familiar with categorical logic if you did any critical thinking courses like Phil 6? No? Okay. I'm asking only because if you were, then yay, good for you. You can bring that to bear. So categorical logic is divided into 2 versions of the system. There's the traditional or Aristotelian, and then there's the modern. We're looking at the modern, but we can kind of piggyback a little bit on some of the thinking that's involved in the Aristotelian logic. So Aristotle's the first to actually develop a system of logical rules whereby you can demonstrate the truth of a conclusion, where the truth of that conclusion is dependent upon the premises. So what we're getting this in our modern system is a version of that logic combined, as you already know, with the propositional logic that we've just learned. So it's like a superpower logic, right? Okay, so let's talk about how we're going to notate this in terms of the universe of stuff. And here is our universe of stuff, which that's a universe of fun too, but I'm trying. Stuff, right? So we have things like tables and chairs. Oh, and tables and chairs are furniture. We have things like dogs, and we have things like cats, and of course those are contained within the class of animals. You get the idea, right? We can talk about the blocks language, right? Like cubes, tets, and so forth, blah, 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 right? So what our quantifier logic allows us to do is to carve up the stuff of the universe, right, without specifying the entities in question in terms of a name, right? So, for example, rather than saying Matthew wears a green sweatshirt, we say someone wears a green sweatshirt, right? So what we're going to be involved with at the beginning here is talking about how we articulate in symbolic logic notation the carving up of the universe of stuff, right? So to that end, we've got to have a handle on our notation. So we already know that we have predicates, right? So we can say something like, A is a cube, right? Notice that when we're talking about unnamed entities, we've got to have a way to quantify them. So if I'm talking about dodecs, you want to know how many. All of them or at least one of them. So here, all, every, or at least one. So the existential, the name existential claim or existential sentence, sometimes called a particular claim or a particular sentence, is a sentence that asserts the existence of, right? The universal, we'll see in the modern system, does not assert the existence of. It sort of suspends judgment about the existence of a member of the subject class. So when we're talking about quantified sentences, we're talking about groups of things, classes of things, categories of things. So the question now becomes, all right, how do I deal with the notation? Well, you're probably comfortable with the idea that the S, which here is just a capital S for subject, capital P for predicate, these are going to remain, right? So let me give you an example. If I say, let me come down here. So we're talking about our universe of stuff. If I say dogs are animals, if I say cats aren't dogs, if I say at least one chair, oops, yeah, why not? At least one chair is an animal. I didn't say I have to make a true claim, right? If I say at least one chair is not an animal, right? I've begun to carve up my universe, right? Okay, so how is this going to go? Well, notice that in the first two examples, there's no explicit quantifier. In other words, we're not told in terms of the words on the board whether or not we've got a universal or an existential. So one of the things, I just want you to file this away because this is going to come up again later. We sometimes will stipulate, right, what our quantifier is, and that will also tell us a little bit about what we're assuming is involved in a domain of discourse. Or we know from experience, or we're told this is what you're going to do, that the universal is implicit, right? The universal is implicit, yeah? So one of the nice things about the work that we're doing is it forces us to pay attention to the language that we're using, at least insofar as that language reflects some beliefs about the logical structure of our universe, right? All right, so dogs are animals. We said implicitly we're talking all, right? So yeah, so all dogs are animals. Yeah. Now, we've got dogs, we've got animals. How do we quantify the all? How do we relate the dogs to the animals? Well, the following formulation is going to do a lot of good work for us. It's not going to be the complete picture, though. So, if it's a dog, it's an animal. Sound fair enough? Do you mind if I erase the universe of stuff, by the way, since now we're writing over it? I know, my artwork was stellar, but... So notice what we've got here. I'm going to grab this one. unnamed thing, right? Does that make sense? So what is the unnamed thing? The unnamed thing is a, okay. So first question for you, does some of this look familiar to you? Sure does. Good. Next question for you, does it make sense to say the following? Right now, this is not a sentence. It's not what's known as a well-formed formula. It simply is a statement function. The following will make more sense once we get to the terminology. These variables are unbound. The most I can say, and I'm already saying too much when I do, is if entity dog, then entity animal. Right? Now, why am I already saying too much? Well, how many entities? We don't know until we specify with the universal and the scope of the universal. So, our symbolic logic notation for the universal quantifier is an upside down A. So, here is our universal quantifier, right? Here is our predicate. Here is our variable. Here is our connective. Our other predicate. Now notice the language that I'm using. It's a logical predicate, not a grammatical predicate here. And then our other variable. Sorry, Connor, you have a question or a comment.
So we don't have a subject in the sentence?
We do. And then parentheses, not parenthesis, Mia, so there's no dot there. Parentheses reflect the scope of the quantifier, which I am now misspelling. Okay, so Connor asked a super awesome question. He said, what do you mean we don't have a subject? And I said, sure we do. But notice that the subject, right, the grammatical subject is a class or group of thing, right? And when we went from all dogs are animals to if it's a dog, then it's an animal. So the it's is the unnamed thing that's a dog, right? So think about our stuffy stuff of the universe, right? Stuff that's dog, stuff that's animal. So we have our logical predication, right? So properties of things, if you will. Yeah? Okay. So all of the notation, except for the upside down A, you already know. We replace the individual constant with a variable, a placeholder, and in our system we use T through Z, right? So the new notation involves, new notation quantifiers, universal, which is an upside down A, existential, backwards E, variables, lowercase t through z. We'll very, 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 very often use X's and Y's. Now there's some really fun and interesting things to say about variables and the domains of discourse and the scope of quantifiers. We're going to get into that, but how are we doing so far? Connor, what are you thinking?
What's the little X next to the universal quantifier?
Oh, great question. Okay, are we ready to read that back?
Sure.
Mm-hmm. Yes, he is. Yes, you are. All right, so we're going to talk about ordinary language for the universal, ordinary language for the existential. So for every X, or for every thing, if that thing is dog, then that thing is animal.
So X is the scope.
So in some versions of the system we learn we don't use the upside down A, we just use the X, and it says for every, we use the backward E, but we just use the X, and it says in this case everything, all thing, everything. Yeah. So we go. So notice, by the way, what happens with the copula. That is the conjugation of the verb to be. So the copula are, or the copula is, connects the two classes, or if you will, separates them out. And then the quantifier tells you about the range of the subject class in terms of its distribution into or exclusion from the predicate class, right? So going back to the big universal stuff that I wrote, I had the nested circles. Dogs are inside the animals class, and you can keep nesting. If you're familiar with Venn diagrams, those are ways for us to visually demonstrate the logical structure of a sentence. Okay. How are we doing? So far, so good?
So you're saying that says that everything in this is also that?
Yeah, everything that's this is distributed into this, or is involved in this. I mean, that would be the easiest, I think, way to say it. Now, notice that this universal affirmative is inclusive, right? In the sense that we're saying that animals includes dogs. Dogs are distributed into animals. If it's an animal, then it's a dog, right? Once we're in this notation, there are things we can do truth functionally, right? That are no different from what we were doing in chapter 4, right? How about cats aren't dogs? How many are we talking about? Yes, every single one. So cats aren't dogs becomes no cats are dogs. And then the if then becomes if it's a cat, it's not a dog. Right? So we have every, any, and the translation is going to be the same, except there's going to be a negation, exactly. So, universal, parentheses, I'm just abbreviating D because it'll be faster, arrow, negation, A. Is everybody comfortable with the following idea? The parentheses show you the scope of the quantifier, right? Similarly to when we think about a negation in front of a parenthetical, then a negation rejects the entirety of whatever's in the parenthetical, right? So parentheses help us with scope. So now I come back to language I used earlier. If you do not have parentheses around the sentence function or the statement function, you have what's known as an unbound variable. You don't have an actual sentence in that case, right? So we'll talk more about that. But just know that, for example, Tarski's World, Fitch, they're good at helping you remember to put your parentheses around. And it gets pretty complicated at times when you have 3 and 4 parentheses. Matthew, what are you thinking?
For the sentence we just created, did you say negation C? Or is it?
Okay, yeah, I'm sorry. I was taking the first. I'm sorry. Thank you. Yeah, thank you, Matthew, and nobody else. For everything, if it's a cat, then it's not a dog. Yes, thank you. Land's sakes. So universal X, open parentheses, capital C, parentheses X, arrow, hook or negation, capital D, parentheses X, close parenthesis. Yeah? At least one chair is an animal. False statement, but that's okay. Sophia, what are you thinking?
The sentence that you were just talking about.
Yes.
What's the D in the case of, like,
Oh, no cats or dogs. If it's a cat, it's not a dog. Yeah? So at least one chair is an animal. Some chairs are animals. There is at least one thing such that. Mouthful, I know, but so we're saying then that some chairs are animals. We can also say at least one thing is both a chair and an animal. It's a good example, Connor, because it's so obviously false to us that you'll remember it, right? Sometimes the obnoxious things we remember better than the ones that are more comfortable for us. Since I managed to run out of room, I'm going to put the sentence over here on the left. So here we say there is at least one thing. The thing is a chair and an animal. Yeah? So I'll tell you a little bit more about the standard form in just one moment. I'll have to erase some stuff to make room on the board, but can you see that okay? So backward E, existential X, open parenthesis, chair, variable in parentheses X, conjunction, animal, parentheses, variable X, close parenthesis. And then lastly, at least one chair is not an animal. What do you think it's going to look like? Yep. Existential X.
Chair as not a.
Yeah. So existential X, CX, conjunction, not AX. So for our ordinary language sentences, we've got things like all, every, any. You're going to use your understanding of articles, right? So, for example, the article A can, depending on the context, be a universal or it can be an existential. We're going to talk more about that. So, universals. And then for existential, there is one, at least one, there exists one thing, at least one thing such that some, okay? So these are the standard translations in terms of ordinary language. What I'd like to do when you're ready is to erase part of what's on the board so that I can offer you the standard translation that you want to have in your pocket for when translations get more complicated. Please know in advance that most of us have trouble with translations, particularly as they get more complicated, right? It's they're not easy very often. So obviously there's a baseline proficiency that we want, but what I'm also after is this. Even if you're struggling with a translation, I'd like to see you be able to think about how you might go about the translation so that when you see what's presented as the accurate translation, you say, I've got it, I see that, right? there are times when I'll struggle with something, and I want to share with you in the text a particularly difficult sentence in terms of really grasping what the logical structure is, but share that with you to say, look, this is not something I would obviously get. It's something that I have to work at. But what's really fun about working at this stuff is even if I still don't get it right, I have a much better grasp than I did at the very beginning when I first started, right? Okay, do you mind if I erase? Last chance. Okay, here I go. All right, so aren't you happy that this is stuff you already know? All right, so here are the 4 standard forms. So we want to bear these in mind for a couple of reasons. One is for translation purposes. The other is for when we start, let me rephrase that. For translation purposes, particularly when we start talking about multiple quantifiers, but also, yeah, it's going to be awesome. But also for when we start working on eliminating and introducing quantifiers, right? So we only have 4 more rules to learn. That's it. What do you think they are in terms of derivation rules? Given what we already know about our rules, they've come in sets of and
Existential intro and existential elimination.
see, you already know. Isn't that great?
It's not on the rule sheet though.
Huh? It will be, because you're going to get another rule sheet. I know. Don't say I'm not a giver. Oopsie. Isn't this awesome? They're like, yeah, I already do this. I know how to do that. This is it, by the way, that's it. Those are our 4 sentence types.
Might as well just give us
Boom.
the final note.
What? Yeah, might as well just take the final minute. Some people are now saying, this I haven't heard before. At least I don't think I've heard it before. People are going, hey, since we can't do a retest of the final, can we take a pre-test? Okay, so is everybody clear? So
Yeah.
for every x, if x is an s, then it's a p. For every x, if x is an s, then it's not a p. Rephrase. There is some x, or at least one x, that x is an s and a p. And there is some x, that x is an s, but not a p. What do we think? So far, so good? Yeah? All right, so when you're thinking about these sentences, similarly to what at least some of you did when we were dealing with De Morgan's, you might find that your intellectual habit is such that you interpret a sentence that's articulated either as a universal or as an existential differently. So, for example, the phrase not all, right? Some of you interpret, it's not the case universal, but some of you interpret it as a some are not, right? So you'll interpret it as an existential. We're going to look at equivalences, which I hope will make you feel comfortable about the fact that, yes, in fact, you can interpret a universal as an existential because there are equivalences and vice versa. It's just a matter of getting the notation right. Okay? All right, how are we doing? So far, so good? It's the best. It's just when you thought it couldn't get any better, it just did. Okay. What are you guys thinking about kind of what we have left to do when I say the stuff you did in chapter 6 and 8, you're doing it again in quantifier logic, right? So when you're thinking about your time management, you're thinking about, you know, the other things you have going on in your life, you know, how much time are you going to devote and how often, right? In addition, given the homeworks that you're asked to do, which are meant to have you operating up here so that when you take the exam, which is down here, it's easier, you know, how much time do you need to devote to working it? Do you want to get study groups together? How do you want to work your time? So really start thinking about that because we've only got the, you know, really the 3 weeks left. Okay. Questions, problems, confusion so far. We ready to do some super awesome practice? Yay! Okay, so that means I'm going to erase the middle board. Objections? Going. Okay. Okay. So one of the things that is fantastic about the programs to which we have access is they restrict our world, at least certainly Tarski's world restricts our world in terms of seeing, right, to a few objects that can only take a few shapes and a few sizes and, you know, 6 names, right? So one of the things that I strongly encourage you to do as we're working in quantifier logic is, and homework will ask you to do this very often, but make sure that Tarski's world is open so that you can have a visual guide to understanding quantified sentences, right? So similarly to the example that Connor gave us based on the universe of stuff that I drew on the board, the sentence, what was it? You know, some chairs are animals. We go, no, that's not true, right? Because we know that chairs and animals are different types of thing, right? So similarly, we go into Tarski's world and we'll be able to recognize what is true, what is false, based on whether or not the world satisfies a sentence. That said, however, one of the things that we're going to want to spend some time on is understanding domains of discourse. So I'm going to throw a couple of ideas out. We'll come back to them later in some detail. But think about the following. If I open up Tarski's world and I have a whole bunch of cubes on the board, and I say, all these cubes and all those cubes, you and I understand that those implies something, or implies that there is a distinction, right? We've got 2 sets of cube, right? All these, all those. But by itself, quantifier logic isn't going to make that distinction. So we're going to want to make sure that we articulate, carve out our domain of discourse so that the these and the those are specifically articulated. Now, there are times when our textbook doesn't make the carving out that, let's say, I would, not because I'm right, but because I happen to get nervous that if I don't carve out explicitly the domains of discourse, I may be imprecise, right? Now, I think it's on page 296, our authors say something like, look, we will explicitly specify the domain of discourse unless it's understood from context. What's meant by that? Well, you and I know that a cube is not the same type of object, it's not the same shape as a tet, right? Logic doesn't know this. But if you and I know it, we want to talk about all the cubes and the tets, right? We know that we're talking about 2 domains, the domain of cubes, the domain of tets, and they're quantified differently as well. Right? Here's an example of what I mean. Suppose that I say, everyone is happy. I'm talking about a universal, right? What's the scope of my universal?
Everyone?
Everyone. Now, should I stipulate, should I specify my domain of discourse is restricted to people or not? So, for example, I get in trouble with friends very often for the anthropomorphizing of my non-human family, right? So I talk about people. Have people eaten yet? Where people is, Brett Michaels, Aloysius Ferdinand, Joseph K. Dogovich, Stuart Stuffy Chunks Thompson, and Horatio H. Kane. Also Broderman R. Pell, because he's now part of the puppy pack too, right? Now, none of those are human animals, but I call them, so has everyone been fed, right? But suppose that we want to specify humans versus not, we would need to do that in terms of our domain of discourse, right? If I say, okay, I stipulate, or we know from the context when we say everyone is happy, that we're already assuming the restriction of happiness to human beings, we could say this: universal X, happy X. Literally, however, if we don't have this sentence, right? If we don't have the ordinary language sentence, if we just have the logical notation, the scope of the universal is not clear. What do I mean by that? Well, is it a universal as in everything in the universe? Right? So suppose somebody says, the universe is fundamentally good. So everything is good. Or are we saying instead that we're talking about everything in this class of thing? So we've got our absolute universal and we've got our, if you will, relative universal or class universal. So here's how you could stipulate. For every X, if X is a human, Mia, come on. If X is a human, then X is happy. Right? So one of the things that I have a tendency to do, you may or may not find yourself having this tendency too, it'll be more clear when we're talking about chapter 11, but is how much specification of my domain of discourse do I need to make? We've got a universal in either case, yeah? Okay. How about articles? I mentioned this. Oh, sorry, Sophia, what are you thinking?
I'm sorry to cut you off.
No, not at all.
I wasn't here and I said, but what's the point of the X?
It's a variable. So go back to your understanding of the individual constant, right? The individual constant is a name. So I can say, Sophia wears a hoodie. But notice Sophia drops out if I just say someone wears a hoodie. So what do I put in place of that constant? A placeholder, a variable. Yeah? Unnamed entity. All right, how about this one? Going back to the article, suppose that I say a horse is an animal versus a horse is in the stables. What's the difference? What's the difference between those two uses of the article A? What do you think, Matthew?
A horse is an animal universally.
Yeah.
Horses are animals.
Yeah, so a horse is an animal. All horses are animals. Yeah? A horse is in the stable?
It's just a single horse.
Yeah. So there is at least one, or some horses are in the stable. Now, the two logical predicates are nouns or noun phrases, right? So in the stable is not a noun or a noun phrase, but you would say animals in the stable or things in the stable, something like that, right? Just as a technical matter. So one of the things that we want to pay attention to, and this will come up in some of our practice and our exercises, is making sure that we're clear about what the language is saying to us, right? In this case, about quantity. Okay. Now, I mentioned that we're going to get into more of a discussion about domain of discourse, and we'll talk about multiple quantifiers. I'd like to come back to that. That could be something we pick up with straight away on Tuesday. But in the meantime, I want us to have an anticipation of Chapter 13 for the reason that I had mentioned to you earlier, namely that that's part of the heart of our work, right? 6, 8, and 13 are our derivation chapters. So what is it that we're going to be doing? Connor already said we're going to be introducing and eliminating universals. We're going to be introducing and eliminating existentials. And I think that you'll find 2 of the rules are going to feel mentally really comfortable, dare I say intuitive, even though what's going on is a lot of intellectual work that you're just not paying attention to, right? And the other 2 rules that maybe don't feel comfortable right away, maybe, are, upon reflection, reasonable rules. So I'm going to try to give us easy ways to think about them, and then we'll get into the more technical ways on Tuesday. So remember earlier, so let's do this. Let's call, can I erase these? Is that okay? So let's call this our anticipations of Chapter 13. So and then what I hope that there's time for this. I think there should be. I'll just do a really quick review of what's super important about what we covered. Basically, it's what's on this board. But also a reminder about what we will look at in Chapter 11. All right, so remember I mentioned that when Sophie asked that terrific question about the variable, right? I said that we replace a name with a variable if we're generalizing, right? So think about it this way. If I look on Tursky's world and I see that A is a cube, right? Is it not the case that it follows, so something is a cube, which is to say existential cube. Yeah? Question for you. You're comfortable with the legitimacy of this inference, right? So this is a restricted generalization. And we'll see the rule form that goes with the name existential intro, but you're comfortable with this, yeah? Why can I not legitimately infer from the sentence A is a cube, everything is a cube? Even if I look at Tursky's world and in fact, the entire world is populated exclusively by cubes. Why am I not allowed to make that inference? What do you think? Question for you. Suppose, as is my way, I'm driving angry. I'm angry, why? Because for some reason, people in Los Angeles don't seem to grasp some rudimentary rules of the road. let's take, for example, driving on the freeway in the passing lane while everybody else is passing you. Forget being on the cell phone, doing text, reading their script, whatever they're doing, right? This jerk is driving along, going 50 miles an hour in the passing lane. Now, after I ride right up to the bumper, and I swerve, and I'm doing this, and I'm gesticulating wildly, and I'm the whole bit, right? Eventually, because this person is so self-absorbed, I realize I'm not going to get their attention, so I swing out. I'm careful. I make sure nobody's in the second lane from the left. I swing out, and as I'm driving by, I look over, and I'm like, yeah, should have known. And then, of course, to teach them a lesson, I cut them off, and then I continue on down the passing lane. That's what you do to teach them a lesson. Just cut them right off, right? And then they realize, oh, I was being a jerk, and I move over. I should move over. No, they don't. Anyway, now, I look at them and I say, oh, I should have known. What do you think? Who's driving? An old lady. Yeah, an old lady, right? I brought to bear a stereotype, right? And the stereotype is what? It's the result of a generalization, right? This lady's old bad driver, this lady's old bad driver, this lady's old bad, oh, they're all bad. All those old ladies are bad drivers, right? Inappropriate. Why? Because the claim, all old ladies are bad drivers, can be falsified how? Yeah, you just got to find one that's a good driver, that's not a bad driver, right? You need one old woman, not a bad, or not, yeah, one old woman who's not a bad driver, one who's it's not the case that she's a bad driver. Even if it doesn't seem very easy to find, right?
Actually, it's the fun fact is she was she was a driver. She drove ambulances during the Second World War, and she was like a nurse and a mechanic.
Oh, okay.
And so like the Saudi royal family, like the king had no idea she actually knew how to drive. And when they were visiting her in Scotland, she was like, "Oh yeah, we're gonna go for a drive." And then she got in the driver's seat and like scared the hell out of the Saudi king by like going through the Highlands in Scotland, like as a precision driver.
Well done. Well, thank you. Yeah. So there we go. We have one living example that proves the universal false. Okay. So the restricted claim, legit. The unrestricted claim, not legit. But now here's where we need to do more work. But suppose that I do want to prove that everything is a cube, right? What if I just sort of close my eyes, I reach into the bag of names and I pull out a name. Let's call it A. And from the assumption that there is this name A, I derive the sentence A is a cube. Since A was randomly, arbitrarily chosen, that means what I say about A, I can say about anything. So if from my assumed name, I prove the sentence that I want, I can get out of my assumption and I can infer the universal. Looks like this. So in Fitch, the way they talk about it, or the way they show it, is a boxed up. If I can get, in this case, cube A from the assumption that there's this name A, then I can infer everything is a cube. Right? So we'll get to that. The other intuitive, I think, move is going to be this. If it's the case that everything is a cube, does it not follow that A is a cube? Right? I could name as many things as there are names, right? So I could say A is a cube, I could say all the way, like E, F, right? However many names are available to me. When we've exhausted the class of thing as the universal does, that means any name I pick, right? So just as the generalization to the existential is allowable as if you will, an immediate inference, so also the instantiation is allowable from the universal, right? So any instance I can name is allowed from the nature of the universal. Now, what's the only one left? Existential elimination, yeah. So here again, you're going to have, oh, it's so exciting, another strategy. Okay, don't tell me, is there at least one person right now who's not liking logic? Okay, look around, raise your hand if you're at least one person who doesn't like logic. So I didn't see anything, so I'm just going to assume that the one person right now who doesn't like logic is Sophia. Now, from the assumption that Sophia doesn't like logic, right, if I can prove, nevertheless, that Sophia is perfectly capable of succeeding in logic, right, then from the elimination of the existential, someone doesn't like logic, let's assume it's Sophia who doesn't like logic, and I derive from that assumption, nevertheless, Sophia is capable of logic, right, then that means that someone is capable of logic. So we'll end up with the following. We'll have some sort of claim. So let's say we're talking about a cube, for example. Right? If we assume A is a cube and then we generate some sentence Q, whatever that might be, we can say, look, from the elimination, just like the disjunction elimination, right? From the assumption that A is a cube, I've inferred what I want, so that means whatever it is that I want is the case, right? So I recognize that these two, they're much easier to, in a sense, talk about. We're going to talk about both universal intro and existential elim more, but let me try another example. And this is sadly a pertinent example. I oftentimes will use this when there's not some ongoing tragedy, but we know that there are a whole bunch of bodies from the Paradise Fire up north, right? I believe the two bodies from the R fire have also not been identified. But let's suppose that you're a homicide investigator and you go into the medical examiner's office and you say, I want to see the body. And the medical examiner is going to say, well, which one? Right? I've got a whole bunch. They're all unidentified. Right? What does the medical examiner do? Well, the medical examiner with unidentified bodies adopts a naming convention, right? Well, let's assume this is Jane Doe. Jane Doe 1, Jane Doe 2, Jane Doe 3, or John Doe 1, John Doe, right? Depending on how many unidentified bodies you've got, you're going to have to assume multiple names because you want to keep them straight. So when the homicide investigator comes in, there's got to be some name to be put in use, right, for the purpose of getting where you want to go. So we make an assumptive name when we are not in a position, right, to simply assert what we want at a given time. Now that's a whole lot going on in a very short verbal articulation, but I hope that at least gets us thinking about where we're going to go. So we've got our standard form for each of the four claim types. We know that we're going to work on introduction and elimination rules in chapter 13. We also know that we need to dig deeper into a discussion of domains of discourse and multiple quantifiers. That's what we'll pick up with on Tuesday. In the meantime, don't forget, if you want a clean copy of the exam, if you want to work on what we talked about earlier, let me know and I'll give it to you. And then don't forget too, I want to see you so we can make a plan for success for the rest of the semester.